Assalamualaikum warahmatullahi wabarakatuh. We are from Group 1, which will cover about mole balance from kinetic reactor design. In this group, we have Syed Ahmad Ashraf, which is me, Nur Ashikin, Khairul Ikhwan, Nur Shazwani, Vision, and Firdaus Aznan. Okay, about the mole balance. This is some sort of the content. We have reaction rate, general mole balance, rate law, general mole balance, type of reactor, and summary. Okay, reaction rate. Consider this reaction A into B plus C. Negative RA is the rate of disappearance of chemical species A. A act as reactant. So next, we consider the reaction of D into A. RA without negative, rate of formation of chemical species A. A also act as product. Unit of reaction rate, negative RA or RA only. Mole per unit volume per unit time, which is mole dm cube s or k mole ms. Okay, next. Reaction rate for heterogeneous reaction. Reaction that involve two distinct phases, which is solid, liquid or gas. So consider this reaction C6H5CH3 plus H2 to C6H6 plus CH4, which is the catalyst. Okay, reaction rate denoted as RA naught with apostrophe. Unit of RA apostrophe, mole per unit time per mass of catalyst, which is mole over Sg or kilomole over hour kg catalyst. So we move on to rate law. That's all.
Universiti here. Now I would like to explain to you about the rate law. Well, rate law is an algebraic equation that is a function of properties of the reacting materials and reacting conditions. And in any reactions, the condition may involve the species concentration, the T temperature, the pressure, and also the type of catalyst. And for rate law, it is independent of any reactor type. It can be a CSTR, it can also be a PFR or a packed bed reactor. And usually, the linear equation that we use is negative RA equal to KCA. Negative RA stands for the rate of disappearance of A, the reactant A. Then that's why the negative connotation. And K stands for the rate constant that is influenced by temperature. And C is the concentration of the reactant. Moving on to the general mole balance equation. In doing any equation, in mole balance, we must first specify the boundary that we must have. So for this, for any type of reaction, the volume enclosed in that reaction is something that we call as the system volume. And in this reaction, we can see that there is flow rate of the reactant inside, the system volume, and also the flow rate of the product going outside of the reaction. So the general mole balance equation is the rate of input minus the rate of output plus the rate of generation equals to the rate of accumulation. That is the rate that we want, the rate of accumulation.
Assalamualaikum and a very good day to all of you. My name is Muhammad Firdaus bin Aznan, and today I'm going to talk to you about types of reactors. These are the 4 types of reactors that we are going to study in kinetic reactor design. The first one is batch reactor. The second one is CSTR or continuous stir-time reactor. The third one is PFR or plug flow reactor, and the last one is packed bed reactor or PBR. Okay, for batch reactors, it is used for small scale operation. Has neither inflow nor outflow during reaction. Although these reactors can give you a high conversion, but the drawback is that it's going to give you a high level cost per batch. There are variability among batches. It is used for manufacturing of expensive products. Usually this kind of reactors is being used in pharmaceutical industries. It has neither inflow nor outflow. This is the general mole balance for batch reactors. These two terms become zero because no inflow or outflow. So we got the differential form of dNA over dt, which is the rate of accumulation equal to rate of generation, negative RAV. So we integrate it to become the time for NaO to reduce to Na1, and this is the term. That's all for me. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum. My name is Muhammad Khairikwan, 17220. So I will continue my part. That is continuous time reactor, or we call it CSTR. So first, we need to know what is CSTR. Okay. The assumption when we use CSTR is first, it must be steady state operation, and we assume it perfectly mixed. All the liquid are perfectly mixed. Okay, so what is use of CSTR? Usually, CSTR is used for a liquid. Okay, so here I have example of CSTR. So here we have stirrer, there is motor here, and then they have agitator to stir the liquid, and then there is feed, and this is the out. Okay, this is CSTR, the model of CSTR. Okay, from this CSTR, we want to find the volume. Okay, the first one is, as we know that the in minus out plus with generation equal to accumulation. Okay, for CSTR, we have no accumulation. Why no accumulation? Because the flow that in the tank is equal to the flow out in the tank. So we cancel out the accumulation. And then we have FA naught that is in, and FA is out plus generation. Okay, we the algebraic expression and then we find the volume equal to FA naught minus FA equal divided by negative RA. This is the last equation that we got. So that's all from my part for CSTR. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Jan'15 and I will present about the plug flow reactor. Okay, plug flow reactor, it is always in steady state operation, and then primarily for gas phase reaction only, and then concentration varies easily, reaction rate varies easily, no radial variation in reaction rate, temperature control may be difficult, and no moving part. Plug flow is no radial variation in velocity, concentration, temperature, and reaction rate. Okay, next is the mole balance equation is in minus out plus generation equal to accumulation. For plug flow reactor, accumulation equal to 0, so we can get this equation for differential form. For plug flow reactor, dFA over dV equal to negative RA, and then for integral form, V equal to integration from FA to FA naught dFA over negative RA. That's all.
Hi, my name is Vijendra. I'm representing Group 1, and I'll be explaining on the packed bed reactor, which is on Chapter 1, mole balance. So I'll be explaining on packed bed reactor. Packed bed reactor is basically reactor that is running based on catalyst. Okay, this packed bed reactor operates on a steady state where the reaction is mainly occur on the surface of the catalyst. The reaction rate on the packed bed reactor can be calculated based on the mass of catalyst. The catalyst carries out the reaction mainly for gaseous reactants. On the packed bed reactor, there is no radial variation, especially on concentration, temperature, or reaction rate. However, there is axial variations as the concentration moves to the other parts of the reactor. Packed bed reactor, same as for the other flow reactors, does not have any accumulation, as because there is continuous flow of reactant into the reactor and continuous flow out of the product. and therefore we can come up with the differential form and integral form, where the differential form and integral form is carried out based on the amount of catalyst. For the packed bed reactor, the reaction rate have the sign of prime, which indicates the packed bed reactor. As a summary, we can say that the batch reactor has to be calculated based on the number of mole, and in the integral form of batch we would able to find the time of reaction that is required for the reaction to complete. On the other hand, for the three types of flow reactors, CSTR, plug flow reactor and packed bed reactor, there is no accumulation, and therefore we would able to calculate the amount of volume that is used or required for the CSTR to operate. For plug flow reactor, the volume plays a major role, as it is important for us to know the amount of reactant that is required for the reaction to be carried out. Meanwhile, for the packed bed reactor, the amount of catalyst W plays the major role, and therefore we were able to calculate the amount of catalyst required to calculate for the reaction to be carried out. Okay. That's all for my part. Thank you.